Everyone, let's get started. It's 9 o'clock. I know the weather's going to probably keep some people from being here on time or even showing up, but you're here, right? So I had that take-home quiz for you, those quadratics, right? Those two functions I asked you to graph. Okay, so what I'm going to do, I'm going to collect those, all right, and then if you have any questions over those, maybe at the end we can talk about it. If not, I think I'm going to give everybody here a little bonus for being here, right? So turn it in so that you can be part of that bonus group, if you have it. If you don't, same, yeah, a little reward for being here. I know it's easy when you're laying in bed and it's raining outside to just want to stay in bed, right? So if you have it, you're here. Anyone else? Got it, Max?
I debated to
Thank
see
you.
part 1.
Thank you.
I've never seen the part.
Make sure you put your name on it. Thank you. Okay, thank you. All right. So I think it was apparent, and I've had some comments about this, that the quiz was a little bit rough because of the decimals and the fractions and things like that, right? So I'll try and make sure that we do a few problems today where we actually use fractions and decimals again. So last class, we were talking about how to, oh, I'm sorry, I didn't know you had that ready. If y'all have a quiz, turn in, please turn in. Last time, we were talking about, how to sketch a quadratic function. We went through all the steps, right? And the quadratic function I gave to you when I presented on the board, I gave you this generic formula for it. Thank you. Right? Ax squared plus bx plus c, right? And a, b, and c are numbers. A can't be 0, blah, blah, blah. And then from that, we had the steps. What were the steps? First, figure out if it opens up or down. Then find the vertex. Then quick sketch. Then x-intercepts if you have them. Y-intercepts, sketch, right? Okay, that's the procedure here, right? Now, there is another form. This is called, I didn't tell you this last time, this is called the standard form of a quadratic function, all right, the standard form. We have a second form for quadratic functions that looks like this, and it's called the vertex form. And the difference, well, you can see some differences here. You've got a here, you've got a, but instead of all this stuff here with like bx plus c, what you have is x minus h, that quantity, right, squared, plus k. And this, if you write a quadratic this way, it's called the vertex form. And the reason it's called the vertex form is because this number and this number give you what the vertex is. Now, the best way to illustrate this is to actually just give you an example, all right? So I have an example. Unfortunately, this TV was not working this morning, so I have an example for us to look at. So let's take a look at this function, f of x equals, let's see, 2 times x minus 3, that quantity squared, minus 8. All right, first thing to notice is that this is a quadratic function written in the vertex form, all right? And I have it graphed right there. You can see the graph of it there. Can you all see the vertex? What is the vertex of this quadratic function? 3, negative 8. Do y'all see the 3 and the negative 8 in here? Well, here's negative 8, right? This is actually minus 3, so the opposite of this number is the 3, right? And so that's what we're saying here. If you write a quadratic in vertex form, the opposite of this number is your h, and then that number, whatever it is your k. So this form is very convenient because it provides you the vertex just by looking at it, all right? Just by looking. Also, you know what the a is here, right? The a is 2. And remember, a tells you if you open up or down, right? So we still can tell from this very easily whether or not this parabola opens up or down, and then we can identify the vertex. Very nice, right? Yes?
How would you get the y-intercept?
So the y-intercept, we would still, okay, so the two things we'd still need are what? X-intercepts, right? If we have them. How would we find x-intercepts? We set that equal to 0, right? Okay, we'd have to, and I'm going to show you how to do that. And then how do we find the y-intercept? We plug 0 in for x. And this time, since we don't, remember the y-intercept was always c? In this case, we don't have a c, so we'll actually have to go find the y-intercept. Okay? Now, I'm gonna show you how to go and do this. I just want everyone to see the difference between the forms. Yes? Instead of setting, you mean to find the x-intercepts? Or the y-intercepts? You would still have to replace this with 0, right? Figure out, like imagine this was 0, right? 0 take away 3 would be -3. Just square that. -3 times -3 is 9. Then times 2, 18, then subtract 8. I'm not sure if that's what you meant, but. Okay, see the difference between the two forms, right? Now I want to show you, real quickly before we graph this, I want to show you how you can turn this into this form, all right? How we can go from here to here. So how can you convert from here to here? Not that you need to do it, but I want to just show you that this can be written like this. All right, so what I'm going to do here, I'm going to convert to standard form, just to show you. And to convert to standard form, I'm just going to look at this and start doing the algebra. So the first thing I'm going to do, order of operations, I have to do these exponents first, right? I have to actually take x minus 3 and square it. I'll do that up here real quick. X minus 3 squared, and then I do this thing, right? FOIL it out. Okay, I'm not going to do that work. I'm just going to put the answer here. So we have the 2 that's in front. I'm going to say here, the f of x is equal to the 2 that was in front, and then when I FOIL that out up there, you would get x squared minus 6x plus 9. That's what you would get if you did that. And then you still have minus 8 here, right? And then distribute the 2 through. 2x squared minus 12x plus 18 minus 8. Okay, distributing 2 through the blue here. Still have the minus 8. And then collect like terms together. You have 2x squared minus 12x plus 10, right? And so I don't know if you can see on the Desmos over there, do you see the 2x squared, where is it, right? On the left side here, 2x squared minus 12x plus 10. If I have the computer graph that for me, look what's going to happen. I get the same function, right? It's the same exact thing, right? But do you all see this is standard form? Yes? So from going from vertex form to standard form, not too bad, right? You just FOIL that out, and then you figure it out. How do you go this from here to here, though, right? How do you go from here to here? That's harder, and I'm going to do it in a minute, all right? But I just want you to see that this is just another way of writing this. Okay, let's continue. I'm going to take that function over there, and let's sketch it. Okay, so let's sketch now. F of x equals 2. If you're coming in a little late, that's fine. But if you're going to turn in your quiz, please turn it in now. All right, so I want to sketch this, right? First step, does it open up or down? First step, it opens up because a is 2, which is bigger than 0, right? Thank you. Thank you. Names on it. Okay, it opens up. Second step, find the vertex, right? And see, for the standard form, to find the vertex, you have to use a formula, right? But for vertex form, you have it right there, right? It's the opposite of this number, 3. And then whatever number's on the outside, minus 8, it's that number exactly, not the opposite. So I already know that my vertex is at 3, -8. And so now I'm going to do my quick sketch. My quick sketch. My vertex is to the right 3 and down 8. So my vertex is somewhere down here. I know it opens up. So I should have 2 x-intercepts, right? I should have 2 x-intercepts. I just got to go figure out where they are. So for my next step, I'm going to go ahead and find the x-intercepts. To find the x-intercepts, we always set the function equal to 0, right? Not plugging in 0, setting it equal to 0. And so I need to set 2 times x minus 3 squared minus 8 equal to 0. Now, for the homework, or not homework, for the quiz problems and what we did last time, at this step, to solve the quadratic equation, you either had to factor, right, or use a quadratic formula. Those are your options, right? Whenever you have a quadratic in standard form, it's actually a different approach to find the x and, well, you can still do the quadratic formula, you can still do factoring, but you would have to multiply this all out, like I did a second ago. Instead of that, what I'm going to do is I'm going to try and get this thing that's squared by itself. So first I'm going to move the 8 over. And this is the procedure you can use for all vertex form, when it's in vertex form. Just do this. Isolate this thing that's being squared. Add 8 to both sides. Now what do you think? Divide by 2. Divide this side by 2. Divide that side by 2. You get x minus 3 squared is what, 4? All right, dividing both sides by 2. And now you have to take square root on both sides. Right? If you take square root on this side, it goes away. And then you do square root here. And this is where you have to do plus or minus, because we're introducing the square root, right? Plus or minus. So the left side's x minus 3. The right side's plus or minus what? 2. And now this is a little weird looking, but we're trying to get x by itself. Let me add 3 here, add 3 here. And what that really means is x equals, I'm doing plus or minus 2, and I added 3 to it. So I have to look at both scenarios. What's positive 2 plus 3? 5. Okay. What's negative 2 plus 3? 1. Those are my two x-intercepts, you see? And that should match with what we see up there on that graph. So when you are in vertex form and you're trying to find the x-intercepts, try and get the thing that's squared by itself so that you can take the square root on both sides. No quadratic formula, no factoring. Right, what next? Y-intercept. Okay, so for the y-intercept, we're going to plug 0 into the function. So what that means is I'm going to have 2, I'm going to have 0, take away 3, squared minus 8. So that's me plugging 0 into the function. This is what we just did a second ago, right? This is 2. 0 minus 3 is negative 3. Squared minus 8. Just doing order of operations here. Negative 3 squared is 9. So 2 times 9 minus 8, that should be 10, right? That's 18. Take away 8, you get 10. And now we should have everything we need to draw this thing, right? And the drawing's over there, but I'm going to do my own. My vertex, 1, 2, 3. To the right, 3, down 8. So I put a vertex here. Negative 3, positive 8. Wait, was it? No, sorry, not negative 3. Why did I put negative 3? What was it? Negative 3, sorry, positive 3, negative 8. All right. And then my x-intercepts were at 1. Here's 1. And at 5. And then I had a y-intercept at 10, which is kind of way up here at 10. And then I draw a parabola, right? Okay, you get the idea. Okay? So, if you're given a quadratic function in vertex form, what's wrong? You all right?
No, I can't see.
Oh, you can't see it?
Yeah, I'm working.
I thought you were just, yeah, it's not a very good picture. So if you're given a quadratic function and it's in vertex form, the approach for graphing it is similar in some respects, but there are other things that are different. Like vertex is a lot easier to get. Questions?
What happens if I have like a really bad like decimal, a real long one?
You round it? Yeah.
Got it?
Yeah, I mean, you round it. We'll, before, at the beginning of class, I said I'm going to do a problem where we get some decimals, just so we can go through one, all right? But if you have the quiz to turn in, if you're going to turn in, I've already collected it, so please bring it to me.
Yeah, sure. Just put it here.
I got it. Names on it?
Hang on.
All right, so now what I'd like to do is I'd like to show you how to get from vertex form to standard form. I'm sorry, the other way around. I want to show, thank you, how to get from standard form to vertex form, right? So let's, this is a new example, all right? I'm going to say put into vertex form. And the function I'm going to give you, the quadratic function, is the one we just did. 2x squared minus 12x plus 10. Okay, so in my Calculus 2 class yesterday, we had to do what we're about to do, we had to do it about 6 times yesterday in the middle of some other problems that we were doing. So we were working on something else, and we had to do what we're about to do several times. And when I did it, first time I did it, I said, I know all of you have learned this at some point in time, right? And it's taught 2 different ways. And trust me when I tell you that the way I'm going to show you is the way you should learn it, all right? If you've learned this a different way, I suggest you eliminate that from your mind, all right? And I'll try and explain why in a moment, all right? So what I'm going to do in order to convert this into vertex form, remember, we're trying to get to this, right? We're trying to see, can we turn it into something like this? Does anybody know the procedure to turn this into this? What it's called? What I'm going to do? Maybe when I say it, you'll know.
Foil.
Not FOIL. Well, I can't FOIL because there's nothing to, that's already multiplied out, right?
Oh.
Right? I'm going to do something called completing the square. Does that sound familiar to anyone?
That sounds vaguely familiar.
Okay. Well, that's what I'm going to do. And so if you don't remember it, good. Because you probably learned it the way that I don't want you to know it, all right? So what I'm going to do with this completing the square procedure, it's a procedure, all right? And you're going to do it, and there's sets of steps on how to do this procedure. And we're not here to try and talk about why. You just need to know what the steps are, all right? So I'm going to do now what's called completing the square. I'm just going to say complete the square. That's the name of the technique. All right, so here's the rules. First of all, you have to be looking at a quadratic expression. You'll see this? I'm just going to write that down. Forget the f of x in front. I'm just going to start with this. My goal is to get it to look like that, right? Okay. First step of completing the square. First step. I'm going to put the steps over here. First step, you must have a 1 in front of x squared. In other words, in order to do completing of the square, the number in front of x squared has to be a 1. Is it a 1? No, it's a 2. So the way I'm going to address that is I'm going to factor a 2 out. Now, luckily for us, I can factor a 2, can't I? I can. All right, so we got lucky. Anyone else quiz? So when I pull a 2 out, I'm left with x squared minus 6x plus 5, right? Do y'all agree with that? Okay. Now, you are not going to factor this. I know you might be sitting there, oh, I can factor this or some. It's not what we're trying to do, all right? What we're trying to do is this procedure. So right now, do y'all see that I have a 1 in front of this x squared? And I'm going to focus all of my attention now on what's in that blue parenthesis. The 2 is just going to sit on the outside the whole time, all right? Next step. Find b. All right, now remember b was the number in front of x, the x term? Find that b right there. Okay, so I'm going to say something other than this because I don't want to use b. I'm going to say find the leading coefficient of the x term. When we say leading coefficient, all we mean is the number in front, all right? So find the number in front of the x term. What's the number in front of the x term here for us? Negative 6, all right? Negative 6. What you're going to do with that is divide that number by 2. Why? Because that's the procedure, all right? So I would like to do that over here on the side. This is like scratch work, okay? Right now, I'm in the middle of trying to complete the square over there. Okay, I'm in the middle of doing this, and I'm going to come over here and just do some scratch work, SW, scratch work. Okay, I'm taking the number that's in front of the x. Just the number, not the x, just the number, -6, and I'm going to divide it by 2. All right, what's -6 divided by 2? -3, right? -3. Why do you do this? Because that's the procedure, all right? Third step. Square that answer. Square that answer. So the number we just got, we're going to square it, all right? So we're going to take that -3, and we're going to square it. And that gives you 9, doesn't it? -3 times -3 is 9. And now for the very interesting part of this procedure. You've done this. You haven't asked why. I've just told you to do it, right? Take the number in front of x, take half of it, square it. Now what I'm going to do is I'm going to come back over here, and I'm going to rewrite this. Pay close attention to this next step. Do you agree that that's the same thing? If I add nothing, it's the same thing,
Yeah,
right?
nothing will change.
Nothing's going to change, right? Now, it's kind of dumb for me to do that because who cares? You could add 0 to anything, couldn't you?
Yeah.
But the way I'm going to do this is I'm going to take that red part and I'm going to rewrite it this way. Watch. I have, let's see, this is equal to that. This is equal to 2x squared minus 6x. And then I have this plus 0. I'm going to come back over to this number I have here. And what I'm going to do is I'm going to add that number and subtract it at the same time. I'm going to add 9 and subtract 9. Do you agree that that's 0? Do you agree that that's 0? But why? You'll see why, all right? And then I still have plus 5. So this is the same thing, isn't it? This is the same exact thing as this. Now, the reason we do that, okay, the reason we do that is because if you do everything correctly here, right? I should put this step. What did I do? How do you even say this? I added, right? I added and subtracted that number. That number, right? Right after the x term. Man, this marker stinks. Whew. So right after the x term, right, this is the term that has just x. Right after that x term, I added and subtracted that number that I just got. Now, the reason why is this. If you did everything correctly, if you did all of this correctly, something is guaranteed to happen now. These first 3 terms, the first 3 right there, are guaranteed to be what we call a perfect square trinomial, which means that that guaranteed breaks down to be something like x and then something here. It's either a plus or a minus. It's x plus or minus number squared. Now, can anyone look at that and tell me what it is? Maybe not. It's x minus 3 squared. That's what this is. Now, if you don't see that, I have another way to help you with that. See that first number we got? That's the number that will be in there with the parenthesis, with the x, okay? This number will be that number. So what I do here is I write this. 2, okay, be careful with the parentheses here. This parenthesis goes with this parenthesis. And now this in green turns into, oh, there it is. This in green turns into parenthesis x, what? That first number over there, minus 3, that whole thing squared. That's what the green part turns into, okay? But I still have next to it what? Minus 9 plus 5. Well, can we take minus 9 plus 5? Yes, we can. That's minus 4, isn't it? Now, if you don't believe this, just do that. Just to convince yourself. What's x minus 3 times x minus 3? Okay, that's x squared minus 3x minus 3x, right? Plus 9. Put that together, that's minus 6x, right? And that's this, isn't it? That will happen every time. Every time you complete the square, this should happen. And now, continuing, this is 2 parenthesis x minus 3 squared minus 4, right? Close parenthesis. Any questions there? Just put that together, right? Yes?
What about wasn't it negative 8?
Yeah, so where's the negative 8 going to come from? This 2, remember, is outside this parenthesis. So now I'm going to push this 2 back through. And so when I multiply this 2 to here, I cannot put the 2 inside of this because of the squared. So all I do is just slap the 2 in front of it. And then I do the 2 over here, and I get what? Minus 8. And that is what the vertex form is, right?
Find the vertex with standard form.
Pardon me?
So could we find the vertex with standard form and use the a and just write x minus, or like,
Yes, so if you had the standard form, right, you could use the vertex formula, couldn't you?
Yeah.
You could use the vertex formula to get the vertex and then use the A. Yes, I agree. What's important here, right, what's important here is for you to see the technique of completing the square, because in later classes, you're not trying to convert something from standard form to vertex form. You're trying to use this method to break something apart in the middle of another problem. So yes, there might be another way we could get to it, but the technique is the important thing here. Okay, so did I miss anything? I added and subtracted that number, right? Added and subtracted, and then what? The next thing would be that this is a perfect square trinomial, right? So the fifth and last step I guess we could put here is that we have the perfect square trinomial. In other words, something like x plus or minus some number and then squared. And then you have to just, from there, you just put it all back together. Shall we do another one? I think we should do another one. What's probably new to, like if you've seen completing the square before, if you have, what's probably new to you is this little hidden 0. That's probably new. If you've learned completing the square in the past, what they probably taught you was you find this number 9, and then you like add it to both sides of the equation. The problem here is that we do not have an equation. Okay, we are working with a function. It's not an equation. We can't work with both sides. And so that's why we add and subtract the 9 inside like that. All right, let's try another one that's going to be a little bit worse. Hello. So another example. So write this in vertex form. All right, let's go with f of x equals, how about 3x squared plus 4x minus 1. That is a quadratic function in standard form, right? That's a quadratic function in standard form. Let's write it in vertex form. What's the first step?
Factor out the 3, so that we have 1.
Yeah, we need a 1, right? We need a 1. So I'm going to pull a 3. But wait a minute, hold on. We don't have 3s here, right? Like we can't pull a 3? Or can we? Can you pull a 3 out of all 3 of those? We can pull a 3 out of the first one, can't you?
Yeah.
All right, but you can't really pull a 3 here unless you see this. And now you've seen it, and now you know you can. Does that work? What would happen if I multiply 3 back through here? The 3's would cancel, you get to 4. Right? It is, it's a different like level of algebra, right? It's something you don't normally do. But in a calculus class, we do this all the time. So y'all see that? I pull a 3 from here. Okay, I just get 1x squared. Can't pull a 3 here, so what I take is, I take that 4 and I divide it by 3. And now I know that if this goes here, the 3's cancel, I get 4x. And then same thing here. Can't pull a 3 from here, so what I do is I take that -1 and I divide it by 3. So that if I push a 3 through here, it turns into -1. Make sense? Okay, first step's done. Second step, find the leading coefficient of the x term. What's the leading coefficient of the x term? 4/3, positive 4/3, right? So now I'm going to do my scratch work step. Okay, this is my scratch work. I take the 4/3 and I'm supposed to do what with it? Divide it by 2. Divide it by 2. So you could write it like this, right? You could say divide by 2. Or if you want, you could go real old school and say divided by 2, right? But yeah, this is really like which of these feels more comfortable to you? If I do this one, I have to look at that 2 as 2/1, don't I? And then I just flip and multiply by the reciprocal. Or if I do this, I have to say this is 4/3 divided by 2/1, but that's the same as 4/3 times flip and do 1/2, right? Do y'all see? Either way, you should be doing the same operation. What does this turn out to be? Either way, you do it. Yeah, if you multiply across, you get 4/6, right? Or you could have reduced, and this becomes 2/3. 2/3. Okay? So I took the, the leading coefficient in front of the x, right? And I divided it by 2, and I got 2/3. What do I do with that? Square it. Right? Now I'm on this third step. So this was the second step. Third step. I take that number 2/3 and I square it. When you square that, you square the top and bottom, you get 4/9. Okay? 4/9. This is the number that I'm going to add and subtract, right? This is the number that the perfect square trinomial is going to turn out to be. So now I come in here and I say 3x squared. Where do I add and subtract that number? Right after the 4/3 x, right? Right after that, here's where I come in. I'm going to use, yeah, the red was good. I'm going to subtract and add, or add and subtract? Add and subtract. Don't subtract and add. It won't work if you subtract and add. You add the number, then subtract the number. 4/9. What do I still have there, though? I still had minus 1/3, didn't I? So I still have a minus 1/3 there. And all of that was living in this parenthesis with a 3 sitting in front. It looks worse than it is. What am I guaranteed about those first 3 terms? They factor, right? To be perfect square trinomial. So I'm done with my scratch work, at least this part of it.